The topic is representing proportionality in a graph, table, and equation. The essential question is, how can you represent the unit rate from a situation, table, equation, and graph? So the whole purpose of these notes right here is to take everything we've learned so far about proportionality and unit rate and just kind of show you the relationship amongst them in situations, tables, graphs, and equations. And I wanted them all on one page so that you can see how they interrelate and connect, okay? But before we get started on this, I want you to jot down some things you already know about unit rate and proportionality. So go ahead and list them right here. Pause the video if you need more time. Okay, so let's start off with the situation. The situation right here is going to match the table, which will also match the graph, which will also match the equation. These are all interrelated, okay? So it says you travel 420 miles in 7 hours. I want you to find the unit rate given this situation, okay? So to find the unit rate, if you need the support, you would go y divided by x. You have your dependent variable in the numerator and your independent variable in the denominator. And you should hopefully know that the miles you travel depends on how many hours you're in the car or you're traveling, okay? So we want that distance on the top in the numerator, and you want to label it. I'm just going to put m for miles. And then right here, the independent variable is time, and I'm just going to write 7h per hours, okay? So that right there, that's just the rate. To get to the unit rate, we need to find how many miles you can travel in 1 hour. So to go from 7 to 1, we divided by 7. And we also have to divide the numerator by 7 since we divided that denominator by 7. 420 divided by 7 is 60. And that would be 60 miles in 1 hour. So that unit rate is, you can travel 60 miles per hour. Okay, so now we're going to take this situation and we're going to go ahead and fill out a table. And you'll see right here that this is a blank table. So what I want us to do is first label x and y, but leave yourself some room underneath the variables of x and y. X is independent, y is dependent. And we want to label this in the context of the problem over here, in the context of the situation. And I have the x is, well, this has x, and x represents hours. That's the independent variable. And then the dependent variable is y, and you see y right here, and we had labeled that miles. So to hopefully make this make more sense for you, the miles that you travel depends on how many hours you're traveling. Okay? So now you see that there's no numbers right here. I'm just going to go ahead and have you use the numbers 0 through 5, okay? So let's put 0 hours, 1 hour, 2 hours, 3 hours, 4 hours, and 5 hours. Sorry, I kind of ran out of room right there. So let's go ahead and think about this. If you traveled for 0 hours, how many miles would you have gone? 0 miles, okay? If you traveled for 1 hour, how many miles would you have gone? Well, you would have gone 60, as outlined right here. 60 miles for every 1 hour. Okay, so 1 hour, you're going to put a 60 right there. Okay? And you should hopefully know that your unit rate is 60 miles per hour. So you're taking that x value, you're multiplying it by 60 each time to get the corresponding y value. Okay, so 2 times 60 is 120. 3 times 60 is 180. So what this means is if you traveled for 3 hours, you would have traveled 180 miles. 4 times 60 is 240. 5 times 60 is 300. Okay? So there's a table of values. And of course, you could have done more numbers if you wanted to, but I just wanted to kind of keep it pretty simple for you as we start out. Now we're going to transfer this information from the table to a graph, okay? And so something that might help you is recognizing that the values in the table are really coordinates. Another name for coordinates is ordered pairs. Another name for ordered pairs is points on a graph. So this right here, this point is really 0, 0. This one's 160. Hey, when x is 1 and it's a proportional table, that corresponding y value is the unit rate. 2, 120, 3, 180, 4, 240, and 5, 300. Okay, so now let's go ahead and move on to the graph. And you'll notice that the situation matches the table, and both of those will also match the graph, okay? So for the graph, I see that we have blank axes. This axis right here is the x-axis. And this axis right here is the y-axis. That's always going to be that way. And if you're curious about which numbers to put in for x, let's go ahead and look and see what x even represents. Well, x represents hours. So I'm just going to go ahead and number 1 through 5 down here. So this first little notch right there, well, that would be 0. Let's make this one like half an hour. So let's make this one 1 full hour. This would be half an hour, so 1.5 hours, so this would be 2. This would be 2.5 hours, so let's make this one 3. I guess I could put the 0 right there if that helps you, okay? And then this one right here would be 3.5 hours, so let's make this one 4. Here would be 4.5 hours, so let's make this 5, okay? So I am basically jumping by half hours, okay? And we need to make sure we represent that x-axis. See how it's x-axis, or x represents hours. So we're going to write hours right there, okay? Okay, before we write down the y values in our table, in our graph, I want you to read this statement right here, and yes, please write it down. When creating a graph to display a proportional relationship, it's probably the easiest to count by the unit rate when putting the numbers on your y-axis. It's probably easiest to count by the unit rate when putting numbers on your y-axis. Okay? So our unit rate is 60. So when I'm going to create the graph, now you don't have to do this, but I'm just telling you it's probably easiest to count by that unit rate. Okay? So right here, I'm going to make that first notch right there. Well, this one right here is 0. So this right here would be 60. Right here, counting by 60, add 60 to it, you get 120. Right here, adding 60 to that, you would get 180. Right there, adding 60 to that, you would get 240. The next one, add 60 to that, get 300. The next one, add 60 to that, get 360. And you can go ahead and keep on going if you want, but it's really not that necessary. If you feel that your graph looks a little blank, you can keep going a little bit more. And then add 60 more. Okay, so I'm going to stop there for now. And you'll know that it keeps going on forever because of the arrow. All right, so I need to label that y-axis, and the y over here is miles, as it is also over here, miles. So this would be miles, and I can write it like this. Or you could write the word distance, okay? Similarly, you could have written time right here instead of hours. Okay, so see all these ordered pairs right there? Go ahead and plot them. So we got 0, 0. So 0, 0 is right here because this first little notch is 0 because we're counting by 60s. So that's 0. And then we have 1, 60, 160 right there. And then from the table we had 2, 120. So go ahead and plot those ordered pairs. We had 3, 180, 4, 240, 5, 300. Okay, there we go. And right now it's discrete because I haven't connected the dots yet, but are we allowed to have, like, can we travel for half an hour or 1 hour and 45 minutes and so forth in those little increments like that, those fractional increments? Yes, we can. So therefore, it would make sense to go ahead and connect those dots to show a continuous line. And you're going to have to bear with me right now because I'm holding a camera and I want to try to balance, or I mean, keep my straight edge from moving, so this is really awkward. So I apologize if my graph's line is not straight. Okay, and we're gonna put an arrow on there to signify, hey, yeah, you can be traveling for a really long time, more hours than just that's listed on the graph. Okay. All right, so that's what we have right there. You'll notice that right here, this ordered pair is the unit rate. Okay. I'm gonna go ahead and label that just so you know. And do you remember which ordered pair up here is the unit rate? This one represents the unit rate. Remember when x is 1, that's the unit rate. The corresponding y value is the unit rate. And don't you know right here, it's also the unit rate. Okay, so you know unit rate here, here, and also from your graph. Okay, now let's tie it all in together. Okay, let's go ahead and look at the equation. It says use t to represent the time in hours and d to represent the distance in miles. So before you get all stressed out about the t and the d right there, let's start with what you already know, what I've already taught you, okay? Now how I have taught you this is I showed you how to just go ahead and just start with this. Y equals, leave a spot for the unit rate, times x. And what was the unit rate? Well, it's 60, it's 60 times x. Now, what did x represent in everything? Well, that was hours. You'll see x is hours here, x is hours here, x is hours here. And then what does y represent? You know, that dependent variable. Let's look and double check because it's all going to matchy-matchy. Miles, miles, miles. Okay, now that we have that labeled, well, we're almost done. I have to label this. That right there, remember, is the unit rate. You're going to start with what you know. You already know that, okay? Now's the time when we can go ahead and replace the variables. So use t to represent the time in hours. So they want to use t to represent time in hours. So isn't that the x variable? So we're going to just go ahead, and you can erase it if you want. I'm just going to write right over it. Right there. Okay? And then they wanted us to use d to represent the distance in miles. So see how y represented the distance in miles? So I want us to go ahead and we're just going to trace right over that y and put a d. Okay, so there's our equation. D is equal to 60 times t. And that's perfectly fine. Or obviously, I hope you know that you can go 60 times t is equal to d. Okay? So start with what you know and then go back and use their criteria. All right, again, for your summary, I do want you to write this down. When creating a graph to display a proportional relationship, it's probably the easiest to count by the unit rate when putting the numbers on your y-axis, okay? Now, you don't have to, but I'm telling you, it's probably the easiest because look how nicely it turned out, all right? And you'll see more examples in the pages ahead. So you'll see that this page, it asks you to provide the missing information, and you're going to notice there's a lot of missing information. You don't know the equation, you don't know the situation or the table. The only information that's provided at all is just this graph right here, okay? So I want you to take a second and look at the graph, and I'm going to go ahead and show you the summary so that you know what to be thinking about, okay? The summary wants you to answer this question. How did you find the unit rate when given a proportional graph? So here, look, it's a proportional graph, and I know that because if I connected all these dots, you would see that it's linear, and it would pass through the origin of 0, 0, okay? So how do we find the unit rate? And basically, how on earth do you fill out all this other information just given this graph? So for starters, what I would do is I would definitely start off by labeling your x and y axis after you've kind of had a chance to read it. X represents the number of movies rented. Y represents the total cost. So for example, if you rented 4 movies, it would cost $8. If you rented 7 movies, it would cost $14. If you rented 1 movie, it'd cost $2. The reason that it's a discrete graph, which means the dots are not connected, is because you can't go to like a Redbox or anything and rent like 1.5 movies. They're like whole movies that you're able to rent, okay? So that's why this is discrete. So looking at the graph, you should hopefully pinpoint that the unit rate is right here. When the value of x is 1, the corresponding y value is going to be the unit rate. So you know this right here, that is the unit rate, okay? That point represents the unit rate. And the point is 1, 2. That represents the unit rate. Which means this is x and this is y. X is movie, so one movie rented would cost $2, okay? So let's go ahead and, I don't know, you can pick wherever you want to go next. Let's go to the situation. So the situation, it involves obviously number of movies rented and total cost. And since this is a proportional table, you can really use any one of the relationships in there to use in your situation. So I'm going to go ahead and pick this one right here. 11 movies cost $22. It costs $22 to rent 11 movies. And you should pick a different one, okay? All right, now let's go ahead and find the unit rate from this situation right here. Unit rate. To find unit rate, you should hopefully know by now that you go y divided by x, the dependent variable, divided by the independent variable. And the dependent variable is the total cost, because the total cost depends on how many movies you decide to rent. So I'm going to put that cost on the top, you know, the cost on the top, so $22 to rent 11 movies. Okay, and that's not the unit rate yet. We got to keep going down. And we want the equivalent fraction for this, where 1 is in the denominator. So one movie, how much would one movie cost? We divided by 11, divide by 11. 22 divided by 11 is 2. $2 per movie. That right there is the unit rate. Okay, where do you want to go next? You can go to the table, you can go to the equation, it doesn't really matter. For fun, let's go ahead and just go to the equation. Now remember, for the equation, I told you to start with what you know. So we know that, well, when it doesn't tell you to use different variables, like use Q for this and W to represent this, when it doesn't tell you that, use X and Y. Use what you know, okay? So I know that you go Y equals, leave a space for the unit rate, times X, and we know the unit rate, it's $2. Okay? And now we just got to label this stuff. So what does the X represent? Look at the X-axis. You can look at it right here. You can also look at it right here. So X represents the number of movies rented. And Y is a dependent variable, and it represents the cost, the total cost of the movies. So, okay. And right there, that 2 is the unit rate. And what the unit rate means is it costs $2 per movie rented. Okay? And I hope you know that instead of writing it as y equals 2 times x, you can write 2x equals y. That would be acceptable too in my book. Okay. So now all that is left is the table. And I see that the table is completely blank, so I know that the first column is independent, y is a dependent, the second column is a dependent, and x represented the movies rented. And if you're wondering, movies rented, number of movies rented. So number of movies rented, and y represents that cost in dollars. Okay, and the table is empty, but I find if you go 0 to 5, you can do more if you want. And let's go to 6 just for fun, because I have room. Okay, And remember that the unit rate was $2 per movie, so you know that you take all those x values and multiply it by 2 to get your corresponding y value. Or you can use these points in the graph right here. If you look at them, oh, 1, 2. So there's 1 and then 2. And then what else we got? 2, 4. So look, 2, 4. 6, 8, 10, and 12. Okay? And which point on there represents the unit rate? Remember, when x is 1, that corresponding y value is the unit rate. Okay, so this one represents the unit rate. Okay, so look at how much you're able to fill in just from when you're just given this little graph right there. So right now, I want you to answer this question. How did you find the unit rate when you were given a proportional graph? On this page, we're also looking to fill in the missing information. So let's kind of take an examination here of what we're missing. Right here, the situation's blank. The equation right here, skimming through it, I don't see any numbers in there. It just kind of provides us a template of how they want the equation to look. The graph is blank, and the table is blank except for this value right here. So what we're going to do is we're going to use this information to fill in the rest of the page, okay? So it looks like this x value represents the pounds of pears, and then this y value, which is the dependent variable, represents the cost. So what this would mean is 5 pounds of pears cost $8. So we can use that to fill this in right here. It costs how many dollars for 5 pounds of pears? Yeah, $8 for 5 pounds of pears. Okay? So from this situation, let's go ahead and find that unit rate. So remember, unit rate is y divided by x. And since the cost depends on how many pounds you get, I know that the cost is going to be the dependent variable, which is the letter y. So it's $8 for 5 pounds of pears. And I'm going to abbreviate. Okay, this does not say 51 BS. It says 5 pounds, 5 LBS, okay? So let's go ahead and set up that proportion right here. We want to know how much would 1 pound cost. And to go from here to here, we had just divided by 5. So 5 divided by 5 is 1. So 8 divided by 5 is $1.60, or 1.6. Okay, so it's $1.60 per pound. That right there is the unit rate. So 1 pound of pears costs $1.60. Now, I think it would make sense anyway for me if I filled out the table. I just think that's the next easiest step after getting the situation all figured out. I know that I went 5 times $1.60 to get to that 8. Oh, that pen doesn't work. Okay, and to double check, 5 times that unit rate gives me 8, so that matches up in there. Now, everything else in the table is blank, so we can use our own values, but remember to label this x and this is y. And keep in mind, we're going to have to be drawing a graph on here, so I wouldn't pick x values that are giant, because otherwise you'd have to make your graph pretty giant, and I'm just not into that. So I'm just going to go 0 to 5, so 0 pounds of pears, 1 pound of pears, 2 pounds of pears, 3 pounds of pears, 4 pounds of pears, 5 pounds of pears. That seems good. And you know that we're going to multiply by the x value by the unit rate each time to get the corresponding y value, because this is proportional. Whoops, times $1.60 or 1.6. Okay, and you can skip that one. So if you didn't buy any pounds of pears, the cost would be 0. 1 pound of pears costs $1.60. 2 pounds of pears would cost $3.20. You put the 0 on there because it's money. And then 3 times $1.60, so 3 pounds of pears at $1.60 each. Pound would be that for 3 pounds, and then 4 pounds would cost $6.40. And 5 pounds would cost $8. And which ordered pair represents the unit rate? It'd be this one right here. When x is 1, the corresponding y value is the unit rate. Okay, since we know that we've got a table to fill out, I'm just going to go ahead and transfer this information into something you're probably more familiar with. You know how they represent ordered pairs. Another word for ordered pair is coordinate. Another word for coordinate is point. So these are all going to be points on the graph. So 0, 0, 1, comma 1.6, 2, comma 3.2. Sorry, I'm not saying it correctly. 3, comma 4 and 8/10. Or you could say 4 and 80/100, same thing. 4, comma 6 and 4/10, and 5, comma 8. Okay? So let's move on to this table. This darn table is totally blank, so we should probably start off with labeling our x and our y-axis. And then for the x-axis, since it's representing pounds of pairs, I just used whole numbers. I'm just going to count by 1. So this first little notch is 0, and then 1, and you kind of have to write really small. 2, 3. And I'm just going to fill it all in, okay? All right, so hopefully you remember what I said when you're filling in the y-axis intervals. It would make it just easier to count by your unit rate. So that's what I would do. So this would be 0. And it's really kind of challenging because you do have to write really, really small. So my unit rate was 1.6, 1 and 6/10. So 1.6 plus 1.6 is 3.2. 3.2 plus 1.6 is 4.8. Then 6.4. That's a 6.4. And then, let's see, 8. 8 plus 1.6 is 9.6. 9.6 plus 1.6 is 11.2. 1.6 more than that is 12.8, 12 and 8/10. And then the next one, when I add 1.6 to it, is 14 and 4/10. Then the next one, when I add 1.6 to that, is 16. Then after that, it's 17.6. Okay? And x, the x-axis is the independent variable, and x represents pounds of pairs. The y-axis is cost in dollars. Okay, let's go ahead and plot our points. All these points right here, and you know what? We can even plot more, just follow the pattern, because you know about proportional relationships. So 0, 0, 1, 1.6. I'm looking at my table, and you'll see that it just kind of keeps going, and I can go up, up, and up, and up. Keep going if I want. All right, so for example, like 11 pounds of pears would cost $17.60. Okay, let's see. Would it make sense to, right now it's discrete, would it make sense to connect the dots to make it continuous? Let's see, when you're at the store, can you buy like 2.5 pounds of pears? Yeah, you can. Can you buy 3 pounds and 3.25 pounds? Yeah, you totally can. So it would make sense to go ahead and make this a continuous line here. And I'm going to try my best here, using my elbow to hold the ruler, or the protractor, my straight edge. So if I mess up, I'm sorry. I'm really glad no one's watching me right now because I look kind of ridiculous. Okay, I'm going to put an arrow on there because, I mean, you can buy like so many pounds of pears and it would just keep going with the cost, okay? All right, which ordered pair, or which point on the graph would be the unit rate? This one represents the unit rate right there, okay? Because it's 1.6, when x is 1, the corresponding y value is the unit rate. Okay, let's go ahead and start on the equation. It says find the constant of proportionality, and they're calling it r. So they're finding the unit rate, they're representing it with r. Using that value for r, so using their unit rate for r, enter the equation in the form c equals r times p. That represents the relationship between the cost, so cost is c, and the pounds of pairs is p. Okay, so before you get super confused, let's start with what you know. I've taught you y equals unit rate times x. What was the unit rate? 1 6/10 times x, okay? And then let's label it with what you know already. X is the pounds. And then y represents the cost in dollars, so cost. Okay, now let's go with what they said here. R was the unit rate. Okay, it's right in there next to the P. So good, I guess that's right. Let's go ahead and let me do some color coding here. They want us for the cost. It's C. So let's find cost. Does that say cost? Nope, that says cost. So I'm going to put a C. And then the other one, what do they want us to do? It looks like it's a P. They want pounds of pears to be represented with a P. So since X is pounds, boom, okay. All right, so now what was this whole business about the R? That's the constant proportionality. It goes right next to the P. Oh, there it is. So they want the number there, okay? Because that's the value of R, which is the value of the unit rate, okay? For your summary, when you're writing an equation to display a proportional relationship, what should you do what should you do if they want you to use variables that are not X or Y? So look, they didn't want us to use X and Y, so what did you do? Describe it. Okay, it says Mrs. Hopkins will now read a story. Try to fill this out. In other words, yes, fill this out, okay? You notice that there's no situation. You're going to glean the situation from the story. The table, all I have is labeled input and output. That'll make sense once you listen to the story. I want you to fill in the graph and the equation, okay? So all of this you must do after you listen to the story or during the story, okay?
Two of Everything by Lily Toy Hong. Once long ago, in a humble little hut, lived Mr. Hacktack and his wife, Mrs. Hacktack. They were old and very poor. What little they ate came from their tiny garden. In a lucky year, when the harvest was plentiful, Mr. Hacktack had a little extra to take to the village. There he traded turnips, potatoes, and other vegetables for clothing, lamp oil, and fresh seeds. One spring morning when Mr. Hacktack was digging in his garden, his shovel struck something hard. Puzzled, he dug deeper into the dark ground until he came upon an ancient pot made of brass. "How odd," said Mr. Hacktack to himself. "To think that I've been digging here all these years and never came upon this pot before. I will take it home. Maybe Mrs. Hacktack can find some use for it." The pot was big and heavy for old Mr. Hacktack. As he stumbled along, his purse, which contained his last 5 gold coins, fell to the ground. He tossed it into the pot for safekeeping and staggered home. His wife greeted him at the door. "Dear husband, what a strange pot." Mr. Hacktack explained how he found the pot. "I wonder what we can do with it," said Mrs. Hacktack. "It looks too large to cook in and too small to bathe in." As Mrs. Hacktack leaned over to peer into the pot, her hairpin, the only one she owned, fell in. She felt around in the pot, and suddenly her eyes grew round with surprise. "Look," she said, "I've pulled out 2 hairpins, exactly alike, and 2 purses, too." Sure enough, the purses were identical, and so were the hairpins. Inside each purse were 5 gold coins. Take a second right now and think if you can fill in any part of this paper based on that information. And if not, that's okay. We'll keep going. Mr. Hacktack was so excited he jumped up and down. "Let's put my winter coat inside the pot. If we're lucky again, the pot will make 2 coats, and then we'll both stay warm." So into the pot went 1 coat, and out came 2 coats. Okay, think if you can fill out anything in there. Take a second and try it out. They began to search the house and quickly put more things into the magical pot. "If only we had some meat," wished Mr. Hacktack, "or fresh fruit, or 1 delicious sweet cake." Mrs. Hacktack smiled. "I know how we can get anything we want," she said. She put their 10 coins into 1 purse then threw it into the pot. She pulled out 2 purses with 10 coins in each. Each time, what a clever wife I have, cried Mr. Hattack. Each time we do this, we will have twice as much money as before. The Hattacks worked late into the night, filling and emptying the pot until the floor was covered with coins. Okay, take a second. Fill out something in that form. Morning came and off went Mr. Hattack with a long list of things to buy in the village. Instead of vegetables, his basket was full of gold coins. Mrs. Hattack finished all of her chores and sat down to enjoy a cup of tea. She sipped her tea and admired the brass pot. Then with a grateful heart, she knelt and embraced it. Dear pot, I do not know where you came from, but you are my best friend. She stooped over the pot to look inside. At that very moment, Mr. Hattack returned. His arms were so full of packages that he had to kick the door open. Bang! Mrs. Hattack was so startled that she lost her balance and fell headfirst into the pot. Mr. Hattack ran over and grabbed his wife's legs. He pulled and tugged until she slid out onto the floor. But then he looked at the pot again. He gasped. 2 more legs were sticking straight out of it. Naturally, he took hold of the ankles and pulled. Out came a second person. She looked exactly like his wife. Okay, you should have now been able to fill out some sort of situation. You should have some values in the table. You can possibly start graphing whatever values you stuck into your table. And if you know the situation, you should hopefully come up with other values in this column because you would know the output, okay, given the situation that you have observed within this book. The new Mrs. Hattack sat silently on the floor looking lost. But the first Mrs. Hattack cried, I'm your one and only wife. Put that woman back into the pot right now. Mr. Hattack yelled, No! If I put her back, we will not have 2 women but 3. 1 wife is enough for me. He backed away from his angry wife and tripped and fell headfirst into the pot himself. Both Mrs. Hattacks rushed to rescue him. Each grasped an ankle and together they pulled him out. There were 2 more legs in the pot, so they pulled out the other Mr. Hattack too. Just what use does one Mr. Hattack have for another? Mr. Hattack cried angrily. This pot is not as wonderful as we thought it would be. Now even our troubles are beginning to double. But his wife had been thinking while he was yelling. Calm down, she said. It is good that the other Mrs. Hattack has her own Mr. Hattack. Perhaps we will become best of friends. After all, we're so alike. He'll be like a brother to you and she like a sister to me. With our pot we can make 2 of everything, so there will be plenty to go around. And that is what they did. The Hattacks built 2 fine new homes. Each house had identical teapots, rice bowls, silk embroideries, and bamboo furniture. From the outside, the houses looked exactly alike, but there was one difference. Hidden in one house was a big brass pot. Of course, the Hattacks were always very careful not to fall into it again. The new Hattacks and the old Hattacks did become good friends. The neighbors thought that the Hattacks had grown so rich they decided to have 2 of everything, even themselves. The end.
Then you can answer this question. After you filled out the above information, and you must listen to the story to fill it out, which was the most challenging for you? The situation, the table, the graph, or the equation? And how come? On this page, we're also going to fill in the missing information. So let's go ahead and examine what's already given to us. Table's blank, graph is blank, the equation, it just kind of bosses us around a little bit. It says use T to represent something, C to represent the other thing. So we got the situation right here. So in 30 days, the store had 180 customers. Let's go ahead and find the unit rate from that. So to find unit rate, you know you got to go y divided by x. Okay, and let's see, which one depends on the other? Well, the number of customers depends on how many days there are. So 180 customers. I'm just going to abbreviate it like that. In 30 days. Okay, and you know how you want time typically in the denominator. Okay, so let's go ahead and find the unit rate. So I want to know how many customers were there in one day. To do that, I had to divide by 30, divide by 30. 180 divided by 30 is 6. So there's 6 customers a day. Okay, so that right there is the unit rate. Unit rate right there. Okay, and we can go to, let's see, we can go to the table next, or we can go to the graph, or we can go to the equation. It doesn't really matter. I kind of think the table might be the next easiest thing to do because when I get the values from the table, I can just plot them. So that makes it easier, I think. But, I mean, each person probably has their own preference. Okay, so I see the table, it's blank. I'm going to label this one as X and this one as Y. And X represents the days. And Y represents the number of customers. And you can pick any values you want for the days, but just keep in mind you're going to be graphing them later on, so you don't really want to pick giant numbers unless you're really wanting to make a giant graph, okay? So I would just typically go from 0 to 5. 0, 1, 2, 3, 4, 5. Okay, and remember how the unit rate we found was 6 customers per day? We can totally do that over here. Or if you want, you can go up to 30 days and write 30 and 180. But honestly, I don't want my graph to be that big. Okay, but I know that the unit rate is 6 customers per day, so I need to multiply that X value by 6 every time to get the corresponding Y value, which the Y value is the number of customers. If there's 0 days go by, there's going to be 0 customers. So that one's pretty easy for me. After 1 day, there's going to be 6 customers. After 2 days, 2 times 6 is 12. After 3 days, there's going to be 18 customers. 4 days, there's going to be 24 customers. And 5 days, there's going to be 30 customers. Okay? And in real life, there's probably not a real proportional relationship that exists between those, but this is just a math problem, okay? For you to practice proportionality. Right there, that's the unit rate right there. Because whenever X is 1, the corresponding Y value is the unit rate. Okay? All right, let's go ahead and go on to the table. Again, the table's blank. We know that this is the x-axis. This right here is the y-axis. And for the x-axis, I'm just going to count by ones because that's how days are, I guess. That's 0, 1, 2, 3, okay, and then for the y-axis, it's the most easy to count by your unit rate when you're setting up your numbers, okay? You don't have to, but since you have to count consistently anyway, I would just count by the unit rate. You don't have to. So right there, that first little notch would be 0, and our unit rate was 6, right? Okay, so I'm going to count by 6s. So 0 to 6, add 6 more, you get 12. Add 6 more, 18. And then we got 24. And then 30, 36, 42, 48, 54, 60, 66, and you can keep going if you want, but I'm good there, okay? So we could start with the values from the table, and right here, that's that ordered pair, 1, 6, 2, 12, 3, 18, 4, 24, 5, 30. Let's plot these points, and we can even continue the pattern real easily. So 0, 0, 1, 6, 2, 12. And you'll notice that I stopped really paying attention because I know the pattern right here. Okay? And let's see. Would it make, I didn't label anything. This right here is days. And Y would represent the number of customers. So would it make sense, could you figure out how many customers you'd have like in 1.5 days? Yeah, I think that would make sense. Or 2 3/4 of a day. possibly. Let's go ahead and make this discrete graph as it is right now. Let's make it continuous by connecting those dots. And again, I apologize if my graph looks a little funky because it is really hard to hold a camera and hold a ruler or a protractor, a straight edge. Oh, okay, not too bad. All right, and what point is the unit rate? It would be when x is 1, y right there, so that right there that represents the unit rate. Right there, okay? Now let's go ahead and go look at the equation. Use t to represent the time in days and c to represent the number of customers. Okay, start with what you know. How do you make an equation for a proportional relationship? I've taught you this. Y equals unit rate times x. Unit rate was 6. Let's label, label, label. X stood for days. Y stood for, if you forget, look up here, customers. All right, now let's go back and read their little bossiness up here. What do they want us to do? Use t to represent the time in days. So, use t to represent the time in days, and oh, instead of x, they wanted a t. Okay, and then the next part they wanted us to use, because that doesn't look like they want us to use y, they want us to use c to represent the number of customers. So instead of the y, we're going to put a c. Okay, so there's equation. Number of customers is equal to 6 times the number of days. Okay, or you can write 6t equals c. Same thing. For your summary, when you're labeling your table, how do you know which will be the independent variable and which will represent the dependent variable? Answer that question, please.